Howdy, everybody. Hope you're doing well wherever, whenever you are. Sorry, I'm just checking really quick to make sure my screen looks okay. We're here for Everybody Codes 2025, so these are fresh and new, right? We've been doing some prep for this and the upcoming Advent of Code, and we're finally here. So the hope is, we'll do well and things will go okay. And if they don't, that's okay, right? I mean, there's been many years where I've had to get help, go search Reddit or things like that, or I just had no idea of where to go looking or to what to do. So that may happen some of these days. I'm going to try to do most of them live. The videos will release a little bit later, and I'll have to figure that out. It may actually be that I start releasing on Tuesdays through Saturdays instead of Monday through Friday for these Everybody Codes ones, just because of when they release. They release like 4 p.m. my time, and I can't do them. I may not be able to do them every evening for the month of November. But I'll do them as soon as I can, and I'll release the videos when I can. So look out for those videos. Again, if you saw, I posted, thank you so much for the 1,000 subscribers. That's cool to meet that milestone. And yeah, I just really love doing this. Hopefully it's helping you, and I love you guys helping me. So keep the comments and thoughts coming. And I don't know, let's just get to coding. I did read this introduction by myself so I could come up with this cool little dragon image or whatever. Who knows if that's actually accurate, but based on what I saw, I thought it'd be cool to do that. So here, I'll read it for you, and then we'll start into the first day. The night is warm, and the moonlight lazily spills over the rooftops of a small village hidden deep within the mountains. The blacksmith is finishing his final task in the forge, eager for a hot meal after a long day battling iron and smoke. As he lays down his hammer for a well-earned rest, something on the forge's doorstep catches his eye. An egg. But not just any egg. It is far larger than any he has ever seen, its shell shimmering with shades of black, gold, and green. The embers in the hearth are still glowing, so he places the egg inside, thinking he'll enjoy it with a thick slice of bread in a short while. To his astonishment, even after an hour in the flames, the egg remains almost cold, as if the fire holds no power over it. He stokes the forge to its fiercest heat once more, but the egg remains unchanged. He gives up for the night, hoping it will be ready for breakfast by morning. As the village slumbers, the shell suddenly begins to crack. From within emerges a dragon, a duck, or perhaps something caught between the two. The hatchling's small, glistening scales are shaped like feathers, and its wings seem far too large for a shiny creature. Do you think you are the blacksmith who discovered this strange egg? Oh no, you are the creature itself, newly born into the world. But who or what you are? Who or what are you? Where have you come from? What destiny awaits you? I don't think I've clicked this. Oh, okay, there's us. That's us, apparently. The cracked egg. What will we become? Who knows? Okay, and here's the first quest. So I think we just start with part 1. The quest is Whispers in the Shell. There's something remarkable about the eggshell you hatched from. Faintly glowing dots and lines cover its entire surface. Even stranger is the fact that you understand what they mean. It's a unique language that all members of your species are born knowing. After taking a close look, it turns out that the eggshell has 3 separate sections. Each section contains a list of names and a list of instructions specifying how to navigate through the list of names. Before executing the first instruction, you are at the first name on the list. Each instruction begins with the letter R or L, followed by a certain number, which simply indicates how many positions to move, to the right or to the left from your current position. Okay. You're taking a closer look at the first section, your notes. The description says that if you can't follow the full instructions without going off the list, you do as many moves as you can to stay on it. For example, if the next instruction is L3 and you are the second name on the list, you move only one position to the left. The description additionally states that the name you land on at the end of the entire process represents the name of the dragon duck inside the name. Oh, so this is going to be our name. So you're a dragon duck, and you'll find out your name soon. Yeah, okay, cool. Okay, so here's the names, and here's the instructions. So we go right 3, 1, 2, 3, left 2, 1, 2, right 3, 1, 2. It stops here. It doesn't go to 3 and then left 1. So in this case, our name is Fearon. Okay. So I think we just have a VEC of names, and then we have a VEC of these, and we just determine how far to go or not to go. I hate when I do that. I always get not used to the day. So we should have a VEC, a stir. We should return that for the names. And then I think we should have a VEC of car I32s. I've been trying to use I32s more. So let's do input dot split one. Split once. We'll use split once with the new line. I guess I can't. I gotta do it like this then. Dot unwrap. And then we'll just say let names equal names dot split comma. It was a comma separated list, right? Dot collect. And then let moves equal moves dot split. It's also going to be a comma, but we want to do some work on it. So we're going to do a map. So give me the part, and I will do what? I want to return like p0, or I guess I had to do p.cares. Like that to get the first one. And then for the second one, can you do like p1 parse? Probably not. Doesn't like that. So p is going to be a stir. Can I do like nope. P dot cars dot. I actually don't know how to do this. I'll look it up really quick. What I want to do is like but ignore the first character. Oh, it does say you can do this. This only works if the string is ASCII. What? So it says, well, so who is that? It is ChatGPT parse I32 unwrap. Puslet. Oh, I need to return names moves. Oh yeah, I gotta do this in here too. It doesn't like Vexter. Oh, this one I need to collect on. Oh, it's I'll get it right one time, people. There we go. Okay, I just, for sanity's sake, well, here's what we can do. We can do names, moves, like that for sure. But let's print, or actually I saw debug as a thing. I've forgotten about debug. I think I've used it before, but saw someone else using that, and I thought that might be useful. Yes. Okay, that looks all right. Okay, so here's what I'm thinking we do is we like just keep we keep track of a number, but we just make sure we never go past the max. So we do like let max equal names.len. And then we can just do like let pause equal moves.iter. Fold them. And we start at 0. And then we have ACK. And then we have our instruction, we have our direction and our delta. And so the idea is we're going to fold this together. We're going to say for each of the instructions, we're going to try and move up, but not move past max. And so I think what we just do is we just do ACK plus. Ooh, I actually can make these negative, huh? I don't even need a car. I can just make them an I-32 by this. If we do like times P dot car, let's do match P dot cars dot next dot unwrap. And if it's a R, we times it by 1. If it's an L, or if it's, I guess if it's anything else, we like times it by -1. So this is just going to give us our delta now, so I don't even have to track. It'll already be a plus or negative number. So we just add our delta, and we do max max dot min, or no dot min of max dot max 0. So like if we ever go too far one way or the other side, we stay in the bounds. What doesn't it like about this? The return type is, I could do this as I-32. We want to return our name. We need to add the lifetimes. So it doesn't get angry. It still doesn't like this. Oh, this right here. Sararin? What do you think the odds are we get it the first time, everybody? Hey, yo! Okay, so what was happening? That wasn't too bad. 10 minutes or so. I did read the problem. Do I pretend the problem took 9 minutes to read it? No. So like, what was I doing here? Just to recap for part 1. I just wanted to like get our input is the first big thing, right? And so I know I can split once by double new line because the input is like double new line, right? Now, if you're on, I'm doing mine in WSL. If you're on Linux, -n works. It might be, I think it's -n for Macs too now, but it might be RN for Windows. And if that's the case, you just need to add that to split that way. There might be a way to like split by, I don't know. Anyway, so I split by that to get this piece and this piece, and then they're comma separated, right? So I can just do split the names by comma. They're done. I split the moves by comma too, but I want to turn them into an integer value. And remember, if you're going right, you're going one way and left the other way. So my thinking was, oh, well, if it's right or left, I just change what that value is. Basically, R becomes, oh, that might be a more interesting thing, is to just change the character to a negative or a positive and then parse it. Anyway, the idea is take the first character to determine if you're -1 or 1. And then otherwise take the rest of the string and turn it into an I32 and parse it. And then I collect all those. So now I have like all the names and all the deltas. I got stuck up on this. I think it was because the IntelliSense thing, I don't know what they call that in the real world, the pop-up thing was saying I couldn't parse, or at least it didn't think I could parse. Maybe that's because I hadn't given this a type, and so it wasn't able to infer the type. That's plausible. But sure enough, I could. So I looked that up with ChatGPT, and here it is right here in case you want to know. I was like, hey, how do I do this? And that helped get me to that answer. So, you know, not too bad, I guess. Oh, I forgot to update the name of the thing. Quest 1. Whispers in the Shell. There you go. Should I include the quest 1? I don't know. I usually do it like this, huh? Okay. Sorry, that was a tangent. My mind wanders. Okay, but then how? So the question is now that you have these names and these like deltas to move, how do you solve that? So I destructure those. I set my max thing so I can track like how far I want to go to the end, but then I also want to track how I never want to go past the beginning either. So that's what this min, max, and max 0 are. Basically what this is saying is if I ever go below 0, this max should put me at 0, and if I ever go above max, which is the last element in my string or in my vec, it will put me at the last element in my vec. So then all I have to do is just go through all the moves and fold them together by adding them to the previous value, and then I just return that item. Okay, should we try part 2? Not too bad. Maybe. EC. I think it's input decode 225.12. We'll watch it again. And we'll start on part 2. Here it is. Your given name and your place within the dragon duck species has become clear. As you... Oh, wait, what was our name? Sararin. I guess that's my name. Your might be different. As you move on to the next part, your curiosity grows and a sense of purpose stirs within you. This time, the challenge presents you with a list of names to arrange in a closed circle. Each name connects to the next, and the final name loops back to the first, forming an unbroken ring. You can move around the circle as you like, going clockwise or counterclockwise, and completing multiple laps if needed. The instructions say we will find one of your parents' names by correctly navigating this circular arrangement. Let's see. Okay, so we get a similar input. I did change that, by the way. Like the default for part 2 and part 3 is just to parse part 1 the same way. Because I noticed... Oh, you haven't seen my videos on these other ones. I've been working on these. I've been working on previous years, and I noticed like the inputs are largely the same. Even though at the beginning it kind of made me think that they might be different. So far, the ones I've done have all been the same. So anyway, we're going to still be given names and directions. Vidrax, Draka, Fira, Ellerzarus, Virdax. Okay, so it now goes in a circle. Start with the first name and go right 3. 1, 2, 3. Now go left 2. 1, 2. Now right 3. 1, 2, 3. You right back to Virdax. L1, Elizra. This would be the name of your first parent in this example. Okay, so there's a lot more instructions, a lot more names. So how does this change from part 1? We now implement wrapping. So instead of having our mins and maxes, we can do the Rem Euclid. Have I done that before in a video? So Rust has a thing called Rem Euclid, which will figure out the modulus for you. The way this usually works is imagine you're going +1. What that really means is you want to go to 0 now, right? And so if you do the modulus of the len of the list, that now 5 would actually be 0, if that makes sense. And you can, or I guess in this case it's 4 would be 0. Because there's 4 elements, and this would be the 4th element right here. The Rem Euclid is really cool because it also works in the opposite direction. So if you go -1, it then wraps you around back here. So it's quite possible that this part 2, we can all pray, will be very easy, because we should just be able to do names, moves, and reuse part 1. But instead of doing this min max delta, we do Rem Euclid. Names.lane. Like that. It is not happy with me. Why are you not happy? Oh, gotta fix these. Lifetimes. I don't think in this one you really need to do lifetimes, but cannot convert to U size. Why would it convert to U size? Oh, this one right here. Talgarath? What are the odds that I'm saying any of these names correctly? Maybe that's a puzzle. Okay, there you go. Part 2, not too tough. This is just I think I've done puzzles like this before. Hey, the practice, maybe it helped, huh? Um, this rem Euclid function is really helpful, right? Because it basically just says do the wrapping for you. And you could do it yourself, right? You could say like, oh, do it modulus the len, and that would wrap you around this way. However, if the value was negative, it's the I think what it is like for like negative values, it's you do it actually works for all of them. You do like the value plus the len, modulo len. I think that's what you do. This is what rem Euclid essentially does, is this thing right here. You do the plus len because you're going to do a modulo len, and so that has the effect of like negating that plus len. But what it does is if you're negative, it now brings you that it brings you from the end of the list to one back, or and v back, I guess, is maybe the way to say it, because maybe you're like -2. If however you've gone over, then this modulus still moves you back into the right place, and this len is negated because again you're doing modulo the len, so it works out. So just to be clear, that's what this rem Euclid is doing. You do this, and then now you I guess I don't know, maybe you're doing it in a different language too, and so you don't do rem Euclid. Doing something like this has the same effect. It will like turn that integer value into keep it bounded within your range, is maybe the way to say it. Okay, not too tough. Part 3. Should we decode part 3 and watch? The final section also arranges the list of names in a closed loop. However, this time the instructions work a little different. The indicator R or L points to the name relative to the one at the top of the circle, the first on the list, that must swap places with it. Okay, this is going to be interesting. The name at the top of the circle after all the instructions is your second parent's name. So we're going to do swapping now, I think is what this is saying. So we have our 4 names now, and we have our instructions. When arranged closed circle, the names form this shape. Okay, we have the same shape. R3, so 1, 2, 3 means we're going to swap those two. L2 means we're going to 1, 2. So now this is the new one, so we're going to go 1, 2. So we swap these two. R3, so we're here, it goes 1, 2, 3. So now we're going to swap these two. And then L3, 1, 2, 3 means, yeah, right here. 1, 2, 3 means swap these two, which puts Draxif at the top. Okay. So I do feel like, can you do like this? I don't think you can, right? Can you do this? No. I haven't figured out how quite to do that. Like, you can definitely do this, but I've wondered how you like use these as mutable. I know you can do it for like integer values. Oh, you probably have to do this. And then I'm gonna have to do this and this. So I don't need this now. So I think just what I do is I do like moves.iter for each delta. Is there like a vector swap? So I need to know what my pause is. So it's going to be like I should do the rem Euclid. So do the same rem Euclid, but on names.lane as I32. Post the pause. But what we can say, now that we have that pause, can we just do names.swap? 0 pauses usize. Probably have to do that. Airdrivor. We did it. Good job. Okay, that wasn't too bad. 33 minutes in total. I did do it a little late, but what is that? What does this mean? Global place 91? Not too bad. Okay, so what's different here in part 3? Now we're just mutating the values. We're swapping them. This is one thing I do like about the everybody codes is like they tend to build on top of each other. So like think about what we're doing for the first part. We had to figure out how to parse the input, but then we just kind of had to figure out how to like move a single thing around. And then part 2, they said, okay, move it around, but like wrap. So it was wrapping in the thing. And that's what led me to rem Euclid. And then now it said, okay, now you got to swap the positions. And it was like, oh, well, I can still use the rem Euclid. Now I'm just mutating the actual thing till I get to the solution. And there you have it. So yeah, and so that part 3 didn't feel too hard in that respect, because now you're saying, okay, I've already kind of figured out how to wrap around the vector or the list or whatever you're using in your language, the array. So now it's just a question of figuring out which one you want to swap and performing the swap. So in Rust, we have a swap. There's lots of languages that have like the equivalent of a swap. If you were doing it in like very, very old C, actually, does C have a swap? No. I mean, I think you just have a temp variable and you switch them, right? You might be able to use. I know there's like a mim move and a mim copy, but I don't think there's a swap. I'd have to think about that. Anyway. It's been a long time since I've done that stuff, but most of them have this swap. So you just had to figure out how to swap it. And maybe you do it with the most naive way is just a temporary variable, right? So there you go. Okay, so how did today go? I thought it went pretty easy. Not too bad so far. Check our progress. Should we see? I don't. Oh, whoa, wait. Something happened. Oh. Okay, I'm a duck. Wait, I think I said I was a duck dragon, right? And we did figure out my name is Sararin, and my parents are Talgarath and Airdrivor. Okay. Post your solutions. I wonder if Reddit has. I'll post my thing on here. Ooh, someone did it pretty quick. List indexing, clipping, and modulo. Not all that much. Lost 14 seconds to signing in because it wasn't apparent until the challenge unlocked. Oh. But it sounds like this person did really well on the thing. Anyway, I'll post mine on here too, but I'll also post my thing in the description so you can see my solution and give it a try. I don't think it was that hard. I definitely think it's doable. Got it. Yeah, there wasn't anything crazy, but this is a common thing to like actually learning to do this. I do think is helpful, like the rem Euclid, and just modulus operations. Thinking about how do I like wrap around and wrap behind is actually really it actually happens a lot, especially when you're using arrays, and you'll often like ring buffers and weird things like that, circular lists and stuff, implemented as arrays will use that technique to like get values like that. So and there's lots of puzzles that say, hey, I'm going to give you this list, but it's going to be a circle. And you could create, like, in some languages it wouldn't be hard to create a circular linked list where you then just the head of this one, sorry, the tail of this one is this one right here, and then you just go around and around. That would work too. But when you have like a vector or an actual array, it's good to be able to do those looping. So there you go. Quest number 1 in the bag. We'll be back tomorrow. What are these things? Global rankings. Okay. Oh, did I actually get some points for some of these? I don't really do it for global rankings. But it's nice to know. I did do it close to when it started, maybe 15 minutes late, so maybe that was close enough to do it. Head to head. Oh. Okay. You can put me head to head and tell me how well you did. Did you solve it faster than me? What are my stats? Oh, these are the number of, so far only 125, 112, and 110 have opened them. So that's probably why I got decently scored on those. How do they rank? 3 minutes is really good. How long have I been going? 37, and I started like 15 minutes after. So I'm definitely not anywhere close. Oh, here I am right here. I will not be there in coming days, I promise you. I also did this pretty early, so there aren't I don't know if you like it, the previous years when I've done Advent of Code, I kind of like to go look at solutions afterwards. You can't really do that. There's literally only one solution. But here it is in Python. 34 lines of code. What does mine fall under? I do a lot of crazy stuff. 73. It's actually not bad if you think about it. Mine's only twice as verbose as Python. I do a lot of like typing. Not typing as in typing as in the type system. That I probably don't need to do if I was doing it competitively or just for fun. But I like to test those things just to see how I do. So we read the file, part 1. Yeah, you're just adding the deltas, and if you ever go below or above, you stay at 0 or the last one. So same solution. Yeah, he does the same thing to parse as me, right? Or they say get the first character. See, this is so much easier in Python, right? In Rust, it's a little verbose. But again, you do get the type checking. If you have a better way to do this, where the first character is something, and then I want to do something with the rest of them, this is how I've usually done it. Well, when it's something that I'm doing stuff, sometimes it's not just right and left, so you can't just do negative and positive one. But sometimes it's just the character and the parsed version of the rest of it. if you have a faster way or better way to do this, that would be interesting too. I'd love to see that. But they do the same thing in their solution. And then you can just sum them and do modulo. Oh, that's a good point. I don't have to do this for part 2. I don't have to like fold these because at the end of it, I just rem Euclid. That's a cool thing. Like I can literally just do sum dot rem unwrap rem. Oh, I probably have to tell it as an I32 rem Euclid names dot len as I32. Yeah, that does give you the same answer. Was it faster? It didn't look like it was much faster. I mean, there's just not a lot that you're doing. Yeah, it's about the same. I'll keep my original solution. But I'll add a note here. It's like let moves dot iter dot sum I32 dot rem Euclid names dot len as I32. So I think that's how I did it, or that's how it did it, and that works too, right? Why does it work this way? It's because however you're adding or subtracting, you're eventually going to end somewhere. How do I say this? The adding and subtracting doesn't matter until you actually want to determine where the name is. And then you just have to say, okay, now bound me within the range of this thing. And so if it's like -33, it will like properly move you through, right? So that is cool. This is why I like reading other people's solutions, because it does help in that way. So this part 2 is definitely easier. Yeah. Load file 3. He does have a helper function to load them all. For delta endures, delta mod len, name 0. Okay, so this is like the swap. He's doing this swap in the thing. Same thing, just essentially figure out where you're at and then do the swap. So this is something that's also done in I think you do a swap like this in Go as well. Say like, oh, set this value to these two to these two, and it does the swapping for you, and then you just print it out. So okay. Oops. No other. Oh, now we're seeing some solutions. Here's a Rust one. Part 1 notes parse. Okay, so they have a parser as well. Split double line, collect on commas. Bytes filter is ASCII uppercase. I guess this only gets you one. What is iter signed? Oh, he has a utility crate that does it for you. Okay, that's cool. And then he zips the direction and the amount to get like the positive or negative values. Part 1, we fold. Yeah, same thing. Basically the same thing I did. This one's pretty easy, so I imagine a lot of them are the same. Sum, rem Euclid. Perfect. Yeah, this is like a good thing. The rem Euclid is totally helpful. And a swap. So essentially, yeah, the same thing is solved the same way as me. So there you go. Yep. Okay. Yeah, that one was the same. Here's another Rust. People are really into Rust this year. I've wondered if it might be fun. Tell me what you think about this. To like pick a language. So like I list, 15 languages that I've used before that I'm familiar enough with that I'm willing to try a puzzle. Then we try and solve it. So not just knowing the algorithm, but trying to figure out how to do stuff in a language that I maybe haven't used in 20 years. That might be fun. We could also try in a new language too, let's see. I like doing it with Rust primarily because a lot of the programming I've been doing lately has been in Rust, and so learning new things about it I think is helpful. Splitting looks the same. So he does I like this idea too. So this is a potential alternative solution, as you say, create an iterator over the characters, and the first one is the direction, and then you collect the rest as a string, trim parse, and you're good. I don't think you have to trim here technically. Clippy warns me sometimes, but if you're it won't do it here. It won't warn you here. If you're splitting on white space, it will warn you and let you know, oh, I've got rid of the white space. You don't have to worry about it. Okay, so this is a bit more verbose, but essentially doing the same thing is like you loop they're doing a for loop to move around as long as you haven't gotten to the end. Yeah, this can be tightened up again just by recognizing that you can just go add the two number. Think about what's happening. This is like a for loop for n, so the n might be large. Instead, you can just say add the two numbers and then perform a max and min to make sure you're bounded. Parsing, I presume, is the same. And then, yeah, they use rem Euclid based on whether it's left or right. I've always wondered, like, what's the best? I think you've seen me do it before, is where sometimes I do this, unreachable, or I'll do a panic. Or I'll also do just the last one. I'll make it the underscore, like for the rest of them. See what happens. Rem Euclid swap. Yeah, I think the key here in Rust is if you understand rem Euclid and swap, you're doing good. Note to self, remember that different parts use different inputs. This is important. Very good. I've done that before when I was doing my practice problems. I had written a script to help me. I don't know if you've seen, but I have a new shell script that helps me do like these type of things. And I was the way that everybody codes works is different than Advent to Code. With Advent to Code, you just get your puzzle input, and then it doesn't usually change between part 1 and part 2. For this one, your parts do change. You can get all the parts. They're just AES encrypted, and so you go query their system and say, hey, give me the key for part 1, and the key for part 2 won't be available until you have done part 1. Did I say that right? The key for part 2 won't be available until you've done part 1. And so I've done that before, and I had mistakes there, so that's a good thing to remember. Okay, one more solution, and then we call it quits because we're getting to the hour. This is in C#. Yeah. Okay. I have never written a full program in C#, but I've taken some C# stuff, done some minimal C# stuff, just mentoring and helping people out. But I've never actually done it officially. But I presume it's got a lot of similar. So this split, I presume, is like similar to split, but you don't have to collect. In Rust, everything's like an iterator. Okay. Yeah. I mean, the same way. Sorry, I just had to grok what was happening here. You've got a lambda, and then your select is like your map, it looks like. For each one, math clamp, pause. Oh, it's what? Oh, you have a function and then you just call it and return the value? Okay. But clamp is an interesting one because you can do the addition in 0 names minus lane. So I wonder, does Rust have a clamp? I know it has a clamp F. I've used it before. It does. Sorry, I'm looking at it over here. Okay, that's good to know. Min max. So that what is that? What does that mean? I can up here, instead of doing this min max, I can actually just do a clamp 0 max. There you go. Okay, I like that better. Should I just remove this stuff? You guys have seen how I'll leave it around for posterity. GC. That's good to know. There. Okay, so I learned something else. I'm sure I've done this before, time and time again. Clamp is the same thing. So that's good. Okay. There you go. That day wasn't too tough. Let me know how you did. Send your solutions below. I'd love to see them, or just post here on the Reddit and we'll work through them together. I'll read your solutions. You can at me as well, and I'll read your solution. So feel free to do that. Or on, I post my solutions as just on GitHub. You can obviously post them there, I believe. So thanks everybody. We'll talk to you next time. Bye.